Hello everyone, welcome back. In this video, we are going to introduce a new term, asymptote. Before we introduce this new term, which is, by the way, also related to the rational function we learned before. So before we introduce the definition, let's have a quick review about these two lines. So in the picture, as you can see, we have a vertical line. We also have another horizontal line. So quick review, what is the equation for each one? As you can see, the first one, the vertical line intercept with x-axis as at 8. So that's why this line is called x equal 8. Another way to understand this, if you plot any points on this line, you will notice that first coordinate is always 8, right? X coordinate is always 8. So this equation is x equal 8. Another one is horizontal line here, and you notice that this line intersects as y-axis at -2. So that's why this equation is y -2. And another way to understand this, a point on this one, the y coordinate is always -2. That's another way to look at this line. Sometimes students get confused because this line is called x-axis. So sometimes we just assume this one should be x equal to something, but no. So that's why x-axis is also equation as y equal to 0, but y-axis also for the equation as x equal to 0. Because again, the coordinates on this line has x coordinate is the same at the same number, same thing for the horizontal line. So now let's check the equation. Very similar to the lesson we learned before. To start the conversation, we are going to draw the two lines here, where the graph is approaching to. So we know that when we check the two directions for each part, horizontally they were approaching here, and vertically they were approaching here. So with these two lines here, I'm not going to go further to discuss the domain or range. Instead, we're going to stop here and to double check these lines here. So the reason these two lines are very special because this is a line where the graph will be approaching to as we extend it to further places. And since they have very, very special feature like that, we are going to name them based on this definition, lines that the function is approaching to, which means getting close to. Can be horizontally, vertically, or in the future when we learn more function, can be different directions. In this case, we just see these two directions. So this kind of line do have a special name, which is asymptote. So asymptote, the definition is lines where the function is approaching to. For this situation, we have horizontal and vertical asymptote. So when we write down this one, as the reason we review that two lines here, this is the reason. When we write down horizontal asymptote, we can also write down the equation. This is a horizontal line, and they intersect at y-axis at 4, so that's why this equation is y equal 4. And for this vertical asymptote, as you can see, it's go upside down, and if you check where the graph intersect as x-axis at 1, so that's why this equation is x equal 1. So this is how we determine horizontal asymptote and vertical asymptote. Very similar to the lesson we did before, but this time we focus on lines only. Let's check one more example. As you can see here, to help us to determine the asymptote, first thing is always good to just draw these two lines where the graph are approaching to 2. This time let's try the different color. So vertical, I will change it to the blue color. Okay? And then let's write down the equation for each one. So vertical asymptote, again, when we see the vertical line, it intersects as axis at x equal 4 here. So that's why the equation is x equal 4. And for horizontal line, they intersect at y-axis 1. So that's why this is y equal 1. And that's it. That's how do we determine horizontal and vertical asymptote for this situation. I hope this video is helpful. Thank you so much for watching. See you soon, everyone.